Well, we've been cherry-picking companies worthy of merit, and it's a terribly bad thing to say about anybody here, but we came across two quite interesting ones yesterday. MikroE, which is offering some amazing deals to universities for free, actually, for remote embed development, which I think is something you really got to listen to. It's very interesting. And BrainChip, which is neuromorphic computing, which is quite a novel concept, but it's putting intelligence at the edge of a network and telling us what they're doing, how the chip is being developed, and what you can really do when you're managing this stuff.
So neuromorphic computing in general is computing that is similar to the way the brain does it, right? So actually, how do the neurons actually fire? How do they connect to other neurons? And how does it move forward? Traditionally, what we see today as neural net acceleration is really done more as a lot of parallel activities, right? But not often a lot of those activities or computations are thrown away. Whereas in neuromorphic, you're minimizing the amount of thrown away computations. You're event-based, so you only compute when you need to, and you only connect to the neurons that you actually then need to propagate it to. So usually, neuromorphic has been something that is analog because brain is analog. So I would kind of categorize it as we're more event-based rather than purely traditional neuromorphic, which is more analog, right? So what the BrainChip architecture does is it still has these nodes, which are neural processing engines with very co-located memory. So it does more at-memory compute. But it's also connected with an intelligent mesh that can connect these together and also understands how to trigger the next neuron or node process. I mean, AI in general, right, is the ability for a machine to kind of learn, right, on its own at some point. First train, then on its own. And what we are doing is providing the infrastructure and the architecture to make that easier. Now, let's be clear that currently the architecture is based for inference at the edge. It's not designed for training, right? But there's nothing inherently different in it that it can't actually do that if you wanted to scale. But one of the main motivations for BrainChip was to be able to do intelligent computing at the edge, which means disconnected from the cloud. A lot of devices that you see today actually are input points, but send all the AI computation, even inference, to the cloud. Whereas BrainChip and a number of other partners are trying to do fully capable AI inferencing at the edge without needing to go to cloud.
I'm coming from the company who is focused on standardization and time saving. So how we do those two things is through our products, through our concept. So what you see here is the Planet Debug, is the concept of the hardware as a service. So you could connect to any board in the world from any point in the world and work on that board, really work, programming, debugging, but also at the same time see the board with live streaming. So it's kind of that you have a very long cable to the board on a different continent, and have at the same time Netflix delivering live streaming to you. So all those things you have in Necto Studio, extremely beneficial. So the first thing, you could work on a hardware you don't have. So like a rent-a-car. So if you need a car for 10 days, you will not buy the car, you will rent the car. So here, you want to finish some project. It's better to rent the board and finish your project instead of buying the board. And it's not only the buying, you have to wait of delivery, wait of the service someone is have to ship to you. And then what if you didn't buy everything? What if you need to buy something more? The most of the engineering life is just waiting. You are waiting component. You are waiting boards, you are waiting some software patch, you are waiting someone to produce, you are waiting first prototypes, you are waiting. Let's cut the waiting. So that's why you see under the MikroE you say there is a written time-saving embedded tools. It does not say the best, the most expensive, the most cheap. It says we are focused on time-saving. So just imagine, for example, you want to try RISC-V. Everybody talks about the RISC-V and you want to try. If you download Necto Studio, which is free for non-commercial use, you could took from the Planet Debug the board which have RISC-V, and you could work on RISC-V to see how fast is it. Is it easy to program? Is it any difference to the ARM? So my question, for example, what is the difference between ARM and RISC-V? You have to work the same project on one microcontroller and another architecture, and then you will see the difference. So what we offer you here is this time-saving approach to your project, to your knowledge, to your education. So it's the ideal for universities. So just imagine all the students could work as much as they want, as long as they want, on a hardware which is perfectly working, and everything is working all the time. So they don't need to, is it my computer, is it my board, I missed this, I missed that. So they could really work and learn. Also design service company. We are all working now from home. You know how we came to this Planet Debug concept? In the pandemic. I was sitting one day, I was thinking, it will be really good that my person which is working from home have this board right now so he could finish something, etc. And then we say, but we have at that time we have already code grip, which is a debugger over the Wi-Fi. The only thing we are missing is the image. So we add camera and live streaming into Necto Studio, and we came to the concept Planet Debug, which is I could program, I could debug, and I see the board in real time. So that's how the Planet Debug concept has been born.
You could call them simple, but that simple itself is getting more complex. For example, can you actually have a small battery-operated device that not only does kind of a vision process, but actually prediction process as a result of it? Right? So for example, we just announced the second generation of our IP, which can now potentially do a full high-definition video object detection at 30 frames per second at under 75 milliwatts of power in a 16 nanometer. And so what that basically does is really moves your ability to do very complex tasks to small footprint, low-power devices at the edge, suddenly now scaling that ability to get the broader AI results from edge devices. So for example, if you look at 2030, there's going to be data centers, maybe there's 10,000 to 12,000 data centers, but at the same time there's going to be 1 trillion plus devices connected to that. Now if all of them were sending all the computation up to cloud, it would explode, right? So there's a huge amount of data, there's a huge amount of compute being needed, so you need to find ways to distribute it and do it closer to the sensor itself to truly scale intelligence and even global intelligence.
We sell our products, so you could buy board from us, you could buy a lot of peripheral boards. We are famous for those click boards. But concerning the Necto Studio, it's free for non-commercial use. So all the students, you as in your company, for example, if they want to program something which is not, or learn something or try something which is not commercial, that you don't need to pay anything. If you use it for commercial products, you have to pay us $29. But it's not for one compiler. There is 6 compilers inside. You have a compiler for PIC, DSPIC, PIC32, ARM, AVR, RISC-V. So you get only 6 compilers in one IDE. Plus, for each microcontroller, you have more than 1,000 examples, and even complex ones. So just imagine how much time you could save. As much you use it, you save more time. But the good thing is and the important thing is your experience. You have to download Necto, and we have it for Windows, for Mac, and for Linux. It's our own IDE. We make it from scratch. So download it and enjoy. Try. It does not cost you anything, and you will have a benefit from one of those 1,000 examples. You have ready-to-use boards. At least 100 or something is waiting for you. And in case you don't need anything from us, means you don't need some special setup with special clicks, etc. It's free. If you need us to do something specially for you, it will cost you $4 per day. So most of the time you will finish your project in 10-15 days. $50, $60. And you have it, but let's not talk about the money. You have it the same day, in an hour. And in case you need something to be changed, no problem. You will not wait anything. We will change it, and you just continue to work.
I think you hit on two very key points here, right? One is just the explosion in the amount of data going back and forth. And two, the thing you mentioned is how do we secure it? The more data you generate and the more raw data you transmit, the more exposed you are. So if you handle the compute closer to the sensor, one, there is context and better computation because you're not thinking about it as a generic thing, but a distributed thing that is specific to sensor. You're only transmitting metadata rather than raw data. So you're reducing the amount of data being transmitted. And three, you can limit or eliminate the transmission of sensitive data, thereby ensuring stronger amounts of security and privacy.